So our next speaker is Robert MacDowall. He's the chief of the Planetary Magnetospheres Laboratory at NASA Goddard, and his talk is on solar energetic particle alerts based on solar type 3 bursts and high energy electrons. So Robert, are you online yet?
I am online. Can you hear me?
Great. Yeah, we hear you. Yeah, go ahead. Thank you.
Okay.
Can you start up your webcam?
Webcam. Well, I thought webcam. I can see myself on the webcam. Why can you not see it?
See a button on there.
Yeah, do you see a start my webcam button?
We may have. I'm on Plan B here. But some of you will appreciate that I'm giving my talk sitting on the steps in a building at the University of California, Berkeley.
Nice.
So,
just down the road from us.
Yes.
Should be a button over his.
I'm sorry the webcam's not working. I can see myself, but that doesn't really help me much.
You don't see a button in front of the image of yourself?
Right. I don't find anything that's not set the way I think it would be. So.
Okay. We'll just take a few more seconds, and then if not, we can just go ahead without.
Do you see Greg's image?
Yes, I see Greg. Greg, in some sense of the word, is where I should be.
Above Greg's head, there's a button that says webcam. Do you see anything there?
And let me try that again.
Good.
I think it's working now.
And
then there's an enable.
Is your camera? Do you have any? We see where you should be now, but you have to accept your webcam. Is that available?
I did accept the window. So the window popped up, and I did click on accept, or whatever it was I clicked on.
Yeah. Okay. All right. Well, I tell you what. Let's just go ahead in the interest of time. Wish we could see you, but hearing your talk is the most important, certainly. So go ahead.
Very good. Okay. This talk is about using solar radio bursts as an alert for solar energetic particles, which has to some extent been used in the past, but not really implemented as well as it could be. There we are. So the goals for this talk are that the solar energetic particles and galactic cosmic rays as well, which present hazards for robotic and human exploration of the moon and elsewhere, should be understood better. You can imagine that these bursts provide a short time early warning, allowing for various mitigations, like getting behind some sort of shielding or moving your equipment behind some sort of shielding. And so in this talk, for the sake of time, I'm just going to focus on the use of the radio burst as proxies. And in the figure on the right, you see a collapsed ceiling of a latitude, which might be an area that you could move into for shielding from solar energetic particles coming from a certain location. So I decided to focus on a particular set of events. When you blow this up, you can see things adequately, but I'll tell you what's there. These date from late 2003, when the sun, nearing the end of that solar activity cycle, cycle 23, produced a number of bursts over the course of a couple of weeks. In particular, there were, as it says here, more than 40 coronal mass ejections, 8 X-class flares, and 5 large solar energetic particle events. The plot, that's interesting. You see the Bob has now appeared as a picture, which is a good thing. Actually, I don't quite look like that anymore, but it's pretty close.
It's a good shot.
Continuing, the plot on the right has 3 panels. The top one is the medium frequency electrons, and then we have protons and more energetic protons. And so we're going to, in subsequent slides, we're going to focus on the panel from the bottom. This covers the time interval of the 5 SET events, as you can see in the scale at the bottom. So just as a note, this was a sufficiently intense period of activity that they were able to see, if they looked in the right direction and had the dark sky, they were able to see aurora from Houston, which is that's someone from Texas. So, okay, here going from 1026 through November 7 of 2003. You see that if you look, you see there are there's a lot of activity, but there are 3 peak events. The first one on the 26th, and then on the 28th and the 29th, and then on the 2nd and the 4th of November. And these energetic protons are going all the way up to 500 MeV is the profile of closest to the bottom of the pool. I hope you're not hearing that. I'm not doing it. So very briefly, what are these radio bursts? The bursts that we observe at frequencies that are observed by spacecraft outside the Earth's atmosphere are typically called type 2 and type 3 radio bursts. The type 2 bursts come from, if you look at the little drawing on the right, they come from shocks being driven by CMEs, coronal mass ejections, and the type 3 bursts come from energetic electrons from flares, typically on the order of tens of kilo electron volts. And then my colleague, Mike Kaiser, made this drawing which shows what the dynamic spectrum looks like, where towards the left you see a type 3 burst coming from high frequencies down to low frequencies related to those to those energetic electrons, and then you see this more blobby, slower drifting material, which is the type 2 burst. Clearly, for an alert, you want the type 3s, because even though the shock may be important, the type 2 burst is occurring too slowly to resolve that need for rapid alert. So if you look at the data, it might be a little clearer. This is data from the WIND spacecraft WAVES instrument on the left side of the panel, going from the high frequencies around 14 megahertz down to approximately 1 megahertz. You see a rather fast, almost vertical feature on this plot. That's the type 3 burst, and then the activity drifting across the page, the type 2 burst. So for the rest of the talk, we're just going to talk about type 3 bursts, which in large part come from flaring or reconnecting magnetic field activity in the lower corona. There may be a few exceptions to that, but in general, that's the source. So I'm showing you here more wind waves data, but I'm only showing you the highest frequency receiver, called RAD2, for those who are interested. And in it, you see that there are I'm showing two different panels. The upper panel on the left shows two complex type 3 bursts, one of them around the middle of the day. I guess maybe for some I should say a little more about these dynamic spectra. Across the bottom of the plot, in letters which are too small, you go from 0 to 24 hours, and frequency is the vertical axis. 14 megahertz is the highest frequency at the top, 1 megahertz is the lowest frequency at the bottom. So in the middle of the day, for the panel on the upper right, you see this patchy event come down very quickly. It is complex, but it's not very intense. If you go to later in the day, you see a more intense event, which is a complex type 3 burst paradigm. But by comparison, if you look at the panel on the lower left, you see a quiet day when the only type 3 bursts are those very little spikes sticking up at the bottom half of the panel, and where most of what you see, the horizontal bands across between 6 and 12 or 14 megahertz are terrestrial transmissions breaking through the ionosphere and getting to the wind spacecraft. In the next slide, I have a pretty complicated slide, but let me just tell you what's there. You can see in the middle is the energetic proton plot showing the 5 SEP events, and spread around it are 5 days of wind waves data. You can see that each of these, in each case, there's a complex type 3 burst, which results from the magnetic activity accelerating electrons, and that activity is related to the X-class flares at that time. You see that there are 5 events. I've drawn red arrows to show which ones are related, that is, they lead the SEP events. And typically, they're occurring at the same time as the X-class flare. But so you can imagine that they are one proxy, and furthermore, they're a proxy that's easy to detect because all you need is a radio receiver. So from October 26th through November 7th, there are these 5 major SEP events, and each was preceded by a complex type 3 burst at approximately the time of the X-class flare. There are also 2 false alarms during this 13-day interval. One of them on the 26th, that is the panel, the dynamic spectrum on the lower left shows an event that circles. If I was on the moon with a radio receiver like Grad 2, when I saw that, I might think I should go into a shielded area, but that would be a false alarm. However, false alarms are better than missed alerts. So here, on this plot, I show the precision of the red line when the complex type 3 burst can be identified. And that happens pretty quickly. Within a few minutes, you see that it's a complex type 3 burst, and so you have a simple instrument giving you useful information. In summary, the association between energetic protons and complex type 3 burst is well established. Dr. Hilary Kane has worked on this extensively, although there are some details that remain controversial, but they certainly can serve as SEP events, and there's more work to be done there, and I'll try to present it next time. Thank you for listening.
Thanks, Bob. This is really interesting, and one of the things that occurs to me here is obviously this could be a useful tool for folks on our own home planet for a variety of reasons, and I wonder if you have in mind any kind of time frame and what needs to be done to make this a more reliable method.
Well, in the perfect world, I would have presented some of that to the Lunar Science Forum this year. But what I'm currently working on is a complete analysis of the data from the WindWaves spacecraft, because well, first of all, it's the spacecraft that's in the vicinity of Earth. we can also use the stereo wave spacecraft, which have a similar frequency band, and use them to provide different perspectives on the same radio burst. And so that's a useful tangential thing to do. But we use the wind waves data, and we use energetic particle data from the ACE spacecraft and other spacecraft. And we look at it a little differently. Instead of looking at the science and trying to understand the acceleration of the SETs and so forth, we look at it in terms of a more an operational approach, try to define the specific characteristics of the complex type 3 bursts that are giving us the most information. And so some progress has been made on that, and hopefully we will be able to report it in the near term. Let's say before the next before the first or no later than the first survey for.
Excellent, excellent. Look forward very much to that. Really fascinating talk. Thanks so much, Bob. Appreciate